the hydraulic lift. Okay, so for this experiment, we have three examples of hydraulic lift. So the first one is here, the hydraulic jack. The second one is the drawbridge, and the third one is the scissor lift. Okay, so for the first example, we are going to make this one the hydraulic jack. So for the materials, we need a piece of plywood, a saw, uh, two different sizes of syringe, tubing, cutter, lighter, glue stick, candle, two pieces of cardboard, um, two weights, different weights, and the last one is the colored water. And so for the frame of our hydraulic jack, we need to have a plywood and then cut it into our desired dimension. Okay, and then after that, we need to put two holes, two different sizes of holes to accommodate our syringes for the hydraulic. For our hydraulics, so we need two different sizes of syringe and then the tubing. Okay, so let's take out the needle of the syringe first. Take that out. Then the second one. And then let's cut the tubing onto your desired length. And then attach it on the syringe. Now we need to fill the tubing with the colored water using the bigger size of syringe. So we need to take the water. Now let's take colored water from your small syringe and then let's put that in your tubing. Now this will be the final product. But remember, we need to seal the tubing on the syringe with the use. We also need to put two cardboards on the syringe to serve as a platform for your weights. So this is how it works.
And for the principle of our experiment, Pascal's law states that the pressure applied at one point of the liquid is transmitted equally in all directions. This principle is applied in hydraulic jacks for lifting heavy objects. Let's consider two different sizes of piston as an example. According to Pascal's law, when a pressure P1 is exerted over the small piston, a force F1 is applied over the small piston with area equal to A1. This force is then transmitted over the large area A2, thus giving a greater force F2 and leads to a pressure P2 over the larger piston. Say we have an area equal to A for the smaller piston and an area equal to 3A for the larger piston. We have the hydraulic part and the load to be lifted. If we apply a force equal to F on the smaller piston, then according to Pascal's law, we are applying a force equal to 3F for the second piston. This pressure P2 is used for lifting the automobile placed over the larger piston. And we have the formula P1 is equal to P2 or F1 over A1 is equal to F2 over A2.
So for the scissor lift experiment, we need the following materials: popsicle sticks, same size syringe, a piece of plywood, and pins. Okay, so first let's start with the popsicle sticks. Get a push pin and then punch the pin into the center and into the sides. We need to connect the popsicle sticks so as the product will be this. And then we're going to make another one. So for the hydraulic part, we need two similar sizes of syringe and a tubing. So we need to fill this tubing first with water and the other one with water also. So this will be the finished product of our scissor lift. This part is this one earlier. We did also on the other side. And then we connected them at the bottom with a piece of popsicle stick in here and in here. And we placed a guard at the top. We placed the hydraulic and we connected it to the other end of the popsicle stick. So this is how it works.
For our scissor lift experiment, we will use the same principle behind our hydraulic jack. Say we have two syringes of equal size. Once we lower the plunger on the first syringe, then we will create a pressure in here. Pressure is equal to force over area. When we exert pressure in here, we will have a force exerting in here, the tendency of which is to exert also a force equal unto the second plunger. Once this happens, the volume on the first one will decrease and the volume on this part of the syringe will increase. Then the plunger will then push the popsicle stick to go up. And here is our demonstration. Now, as you can see, this one, the volume on this one decreased, and on this one it increased. And then it pushed the popsicle stick to go up because it experienced stress.
Now for this experiment, we're going to make a drawbridge with the principle of hydraulic behind. So for the materials, we need the following: rubber bands, pins, popsicle sticks, tubings, candle, lighter, glue stick, syringe, scissors, cutter, masking tape, and styro. So first, we're going to make the bridge part. So for the bridge, we need the following materials: the popsicle sticks, the glue stick, the lighter, and the candle. So you need to design your bridge. It should be sturdy. It should be well designed. Now for the base material should be made of styro, and we need the following materials. We need the needle of the syringe, the rubber bands, masking tape, and then we need the glue stick. We should place the base of the bridge in a sturdy material like this plywood. Now, this is where the hydraulic part enters. We need a syringe, two of it, and then the tubing. We need to place water inside the syringe and the tubing, and this is where the hydraulic part of which enters. This is how a drawbridge functions.
For our drawbridge experiment, we will use the same principle used in our scissor lift experiment. We have here two syringes of equal sizes. And as we lower the plunger in here, we will exert a pressure. Thus, it will decrease in volume. But the force will be transferred into the second syringe. This will then expand, and then the plunger will push the bridge to go up. And for our demonstration, here we go. There you saw. As we pushed it down, this increased.
Multiplexer, king of memory man.